All right, dude, we are live. What's up, guys? This is Dem Keys, and whew, I'm back after, I don't know, a week of not streaming. Um, I had some IRL stuff come up, because of which I had to kind of change my schedule, and because of that, I wasn't able to stream. And then it took me a couple of days to kind of get back into it. And yeah, today I just barely managed to stream. We're gonna stream for maybe an hour or an hour and a half today, which is our usual stream time. Probably an hour. I don't know. I'll have to see. And then hopefully, if I stream tomorrow again, then so the good news is in the next coming week, I think in the next, well, I don't know. I think yeah, in the next coming week, um, I'm gonna have the opportunity to stream during a different time of the day as well. So I don't know how that's gonna go. I'm gonna have to see like how I'm gonna go about doing that. Who knows? Maybe I might be able to stream twice during the next week. I'll have to see how to go about doing that. But all that being said, we need to get back to data science and transformers. So yeah, yeah, I need to I need to continue my data science studies. I need to get back to learning about neural networks. We kind of paused after the last time we built a neural network. I didn't get a chance to go deeper into that because I kind of got distracted with a bunch of other data science stuff because dude, there's just so much to explore in data science. There's just an insane amount of stuff to explore in data science. For example, I don't know if I have that here. Okay, what I could do is maybe I could, so let's run this. What data set did I add here? I guess I didn't add a data set. Okay, let's add one. Um, which one should I add? So these are all image data sets. That's not what you know what? No, I don't need data sets for what I'm trying to explain. I want to talk about the standard scalar in scikit-learn. So let me just so we have transformers. We'll get back into the transformers thing in a bit. Oh yeah, also before I had my IRL thing because of which I wasn't able to stream, I was doing just a second. Okay. Before that, I did actually start doing a bunch of other things with the Transformers library. More specifically, I'd been focusing on, and this was, I think, the last stream itself. I more specifically, I'd been focusing on what all was it? There was object detection, there was depth estimation, and there was image segmentation. And I was super interested in image segmentation because it was interesting. Okay, so in the last stream, I believe, let me check what the last stream was. I think yeah, the last stream I was looking into yeah, yeah. I was doing image segmentation, and I was trying to figure out the logic for sort of printing out the segments, if it makes sense, because like you, for any given image, when you pass it through the image segmentation model, it's going to give you that same, it's going to divide that image into multiple segments, and it's going to give you one image per segment. So if that one image, the one input image, gets divided into five segments, you're going to get five images which are all the same size as the original input image, but their color is gonna that their color is gonna show you where the segment is exactly, or where a segment has been detected. So that's one great thing that image segmentation models do, but they take it a step further. They actually, not only do they detect segments in an image, they also classify the segments. So the idea is they detect segments. They, I think, from the beginning they're trying to look for something to classify. I don't know if the classification happens before or after the segmentation. I'm gonna have to study image segmentation models to properly understand that. Which we could actually go into creating image segmentation models as well once I learn how to do how to create convolutional neural networks in PyTorch. We can probably explore creating image segmentation models. Okay, now I mentioned that they the models divide an image into segments, right? Not only do they divide the image into segments, they also classify those segments. So in that way, they're able to give you a description of what the image contains. And something interesting about image segmentation models that I kind of noticed after passing in multiple inputs, or rather after testing with multiple inputs, is that image segmentation models are able to see a lot of they're able to see details. Hey Sarah, welcome to the stream. Hello, hello. We are currently discussing image segmentation models. I was just mentioning, what was I mentioning? Yes, I was just mentioning something that I noticed with image segmentation models is that they are able to see details that the human eye might miss at first. So, you know what I should do? Here's okay. I could try and open up the other notebook just so I can show you guys what it looks like. Give me a second. I'm gonna open up the thing here, and uh, I think it was O1. Oh God, don't make it a Google search. What? Okay, give me a second. I'm just opening this thing up. And I already have a data set in there. And after the last stream, after the previous stream, I figured out my code for yeah 2 hours later. Fortunately, now it's a little faster, so I can kind of run things a little bit faster now. But yeah, what was I saying? What was I saying? Hold on. Yeah. So in the last stream, towards the end, I was having some trouble figuring out the logic for kind of reconstructing that same image out of the segments that are given. Um, but in the end, I figured out the logic, and it was actually shortly after I ended the stream, because after I ended the stream, I just carried on working on the thing, and eventually I figured it out. I don't know if the outputs are still there. Right, so I'm going to run this. So we have the image and we have the depth, right? We have image, we have depth. I see two cats and two dogs. Yes, this is, what was this called? I think it's just called cat mode and dog mode. Let me just see in the settings. Was it in settings or view? Oh, it's called corgi mode and kitty mode. I like this. I like this thing that they've set up. Every now and then you'll have like cats and dogs going across the screen. I want to set up something like this for my own VTuber app as well. I just haven't had the chance to do it. So let me run this thing, and is that done running? No, the notebook is starting now, and it is probably going to be downloading a couple of things, and give it a couple of seconds. So, like I was saying, while this loads, I can tell you what my observation was. I noticed that with image segmentation models, because they divide it into segments and they classify each of those segments, right? Because they divide an image into segments and classify each of those segments into something, into a specific class. So they are essentially able to give you a description of what the image contains. Not only that, they are also able to see things that the human eye might miss at first glance. So maybe it's something that's blurry, or maybe it's something that's off in the distance, or maybe it's something that's really small and the human eye doesn't like notice it at first. Or maybe the image just contains many different things, and so human beings, when they're looking at something with a lot of noise, they tend to miss a bunch of details, or they tend to ignore a bunch of details. But with the model, you're able to get all of whatever the model sees, and so you can get an entire description of this kind of you can get an entire description for a scene, for a specific image. So for those of you who know of a VTuber named Neurosama, she's a creation of Vedel 987. That's the channel that Neurosama streams on. So Neurosama does this thing where, or rather, Vedel has set up a thing for Neurosama where she's able to review people's rooms. Sarah, you're asking who? So I'm talking about the VTuber Neurosama. The they A lot of people know her as the AI VTuber, and her creator is Vedel 987, and she also streams on the Vedel 987 channel. So Neurosama does this thing. You don't know who they are? Oh, okay. Hold on. So Vedel is actually live right now. You might be able to see. I think they're doing a dev stream right now. Yeah. So let me give them a shout out real quick. I don't know if I give a shout out. If you're on phone, I don't know if it's going to show up for you. So let me give a shout out with my Nightbot command. Yeah, there's the link. And I guess I'll give a shout out like this as well. Yeah. So go check out Vedel 987. Not that Vettel needs a shout out. He's already got a pretty decent audience. But yeah, for those of you who don't know Vettel, go check him out. Now, what I was talking about, with Neurosama, she's able to, or rather, Vettel has set up a thing for her where he's able to get her to do stuff like room reviews, for example. Now, I don't know what his setup is. I don't know what kind of architecture he has set up, right? But when I was trying to think about how I would go about making something like this, I haven't tried doing it so far, but like I was trying to think of ideas because one of Neurosama's components is an LLM, a large language model, right? So something that I got as an idea, or rather when I was trying to think of, hey, how would I set up something like this if I had to set up something like this? One idea that I got was, okay, we could use an image segmentation model, right? Whatever the image is, whatever the image is, we pass it through the image segmentation model, and then we through that we get a sort of description. Actually, I haven't decided yet if it's better to have an image segment, or if it's better to use an image segmentation model, or better to use an object detection model, or maybe some mixture of the two. I'm not sure. Either way, using one of the two models or both of the models, we then get a description of the various elements that are in the room, because we are able to describe the image through object detection and image segmentation, right? And then once we have collected all of these various elements and objects that are in the room, once we have a list of all of this, we essentially have a sort of description of what the room contains. So then we can pass on this entire list to the LLM, and we can like create a message saying that, hey, this is a room. These are all of the things that we have found in the room. Give us your opinion on what exactly you think about this room. Is it a good setup? Is it a bad setup? Stuff like that. That's an idea that I had. Of course, I don't know if she's been set up. And there's definitely going to be more complexity to her setup than what I've just described. But I want to try setting up something like that, and I want to see how well it works out, because I want to try setting up a sort of bot that can give its opinion on images that you give it. And I guess something else that we could practice there, because there's going to be a couple of different things we are practicing when we try to set up something like this. I'm trying to do it specifically through Hugging Face transformers. Yeah. I'm trying to do it specifically through Hugging Face transformers. And what I want to do is I want to use image segmentation and object detection through transformers, of course, and then get a description of the image, and then pass that description along with a properly formatted message into some kind of LLM. I'm gonna have to see what is available here. I don't know to what extent I'm gonna be able to run. I mean, there's probably going to be some large language models that I'm able to run, and I'll have to see if I'm able to leverage the GPU for it at all. But yeah, I want to try setting up something like that. But yeah, okay. So we were running this. Oh God, I forgot about this. My God, I forgot about this. Why is it printing this? It's not supposed to be. Okay, let's do that. So it's not. Yeah, whatever. So is the thing done running? It's done running. Okay. So now let's import everything. This is just for importing, right? Okay. So this is just for importing. We import all of the stuff that we need, the various modules, the various classes from the modules. And once that is done, we can move on to the next code cell, which, let's see. I think it's this. Yeah. I think it's this, because we have the pipeline over here as well. We have set it up for image segmentation, and the model name is this. We are using this model. Okay. And we set up the whole thing there. And after that, we do, okay, so we basically perform the image segmentation here. And through this, we get all of the segments, which then get printed out. So let's try running that. I think the other code cell is done executing. Oh, yeah, this is probably going to download a couple of things. Give it a couple of seconds. Fortunately, we don't have to wait for like too long, because I'm running Kaggle notebooks. Right. So this is all of these. I forgot what these are called, but like each of the classifications, each of the labels is a separate dictionary kind of thing, and this gives you an idea. These are also the images. So okay, this is the input image, right? And this gets broken up into multiple segments. Each of these segments, you guys can't see it very well. It looks very small on screen, but all of these segments, I assign colors to each of the segments, and then I kind of layer them on top of each other to produce, I think I can do it here. To produce this, basically. I use all of these segments. Each of these segments is what the model has classified as something, right? Um, so let's take an example of let's take an example of, I guess, the last two, which would be these two. It seems to think that these two over here are people. So let's take a look at the yeah, there it is. So there's, I think there's one person here, and then there's I think that's a child there, or just part of a person. I don't know, but yeah, it seems to have recognized a person there. It seems to have also recognized two other people here. So there's the main person in the image, and then there's someone on the side, which we can see here, the main person, and then someone on the side. At some point, I think this person over here also gets classified. Yeah, I think they're here. Oh, wait, no. This is the rightmost person, and this is the person on the left side of that person. But okay, so these are all of the images. I mean, these are all of the segments, and the segments, then I layer them on top of each other to produce this. This is basically all of the image segments that have been layered on top of each other. This is our, I guess we can call it the segmented image. And oh, you know what else we could do? So we have this, right? Something else we could do here is we could now get the label. What am I printing here? I'm printing the prediction dictionary. So, okay. We can create a new thing here. Where's... Okay, why am I not able to create a new cell down here? That's weird. All right, let's create it here, I guess. Oh, is it above? Okay, all right, cool. Um, right, so we have, okay, so we can create a labels list, right? And then we can do for I in, we don't need range, we just need prediction. Labels dot append I label, I think. I'm reading. Yeah, I'm trying to read the label here. And then we can print out the labels list. Oh, I made a mistake here. Let's fix that. Okay, so this is our entire labels list. Now, I still haven't figured out what these are. These I need to look into the model to understand what these types of outputs mean. Like, did it just detect something that it couldn't classify? Because that makes sense, right? If it could classify it, it wouldn't present it in this way. If it presented it in this way, then it probably wasn't able to classify it. Either way, we could remove all of the entries that contain this kind of text, and then we can pass that entire list into some kind of LLM and tell it, hey, this is an image. Dude, you know what else I want to do? Okay, let me finish what I was saying previously. So then we can pass in that list into an LLM and be like, hey, this is a room. This room has so and so things in it. What is your opinion about this room, right? Um, Additionally, I feel like once I'm more comfortable with fine tuning models, I want to fine tune a bunch of different models on very specific data sets. So I feel like if it's a general purpose model, it'll perform well. But if I wanted to perform well on very specific things, then I feel like I need to fine tune the model to I need to fine tune the model on data of that specific type, or rather, how do I say this? So if I want to train, for example, if I want the model to be able to better classify items in people's rooms, then maybe I should be fine tuning the model on a data set containing images of people's rooms. Images, and of course, all of the associated image segments and their labels and stuff like that. I'm gonna have to see if there's some kind of data set available. I'm sure that there might be some kind of data set available for that. It doesn't necessarily have to be people's rooms. It could just be home interiors. Like maybe somebody has made a data set for a data set containing home interiors, and I can fine tune an existing model on that data set, and then the model will perform better when I give it images of interiors, basically. Um, okay, what else? What else? You know what? Let's try playing around with some more images here. So I was using what? Which one was I using? I don't think it was O2. I think it was O1, right? That's what I'm passing in. Yeah. Okay. So let's try a different thing. Let's try image 26. Okay. So let that finish segmenting. And okay, this is a fairly simple model. Or not a simple model. This is a fairly simple image. So let's try some other image. Give it a couple of seconds. The new GPU week has, or the new GPU quota has started for me this week. So I should be able to use the GPU, which would make things slightly faster. Um, but I haven't done that yet. Okay, so this is a good image, I guess. This has a car, it has road, book, person, and this is interesting, right? It's even able to capture the book, which like the book is a part of the person, right? It's the person is holding the book, and a good portion of the book is kind of um, occluded by the person's hand. Yet the model is still able to detect it. I think it's here. Which one is it? Yeah, there it is. It's number three. So that'll be image number three. And if you look at if I print this out, you know what? Yeah, yeah, we can print this out as well. And if I print out both the input image and the segmented image, we can see, okay, the color is a little dark, so you guys probably might not be able to see. Let me try that again. So it assigns different colors. Yeah, there it is. So you can see a bunch of different things have been detected in this image, right? You have the person, you have the person's book. I think this is some kind of vehicle. I don't know. I think yeah, okay. It's some kind of, so this is a car. I think it might be detecting this or this. Oh, it's this. It read the FedEx thing. So it detected that as a truck. I think this is just detected as a car. And then this might be detected as road. I wonder if it detected this as building. Let me take a look here. So we are looking for this, which is number 6. Okay, yeah, it wasn't able to classify this, and something else also. It wasn't able to classify a couple of things. This and this. I think it's because those things in the back they're too blurry, and so it wasn't able to like figure it out. I think this thing in the back is like a tree, or maybe it's multiple trees that we are seeing. I'm not sure. It's too blurry. Oh shit! I missed the ad timer. Okay, there's gonna be an ad starting in like, I don't know, 10, 15 seconds. Um, but yeah, yeah. Okay, so we've done this. Should we just carry on with this notebook? I created that other notebook. Um, I don't want to be running two notebooks consecutively. So, I mean, maybe I could close one because like I don't want to run them consecutively because they'll start eating up performance. Um, but I also don't want to close this just at the off chance that I might want to open it up again later. All right, so there's an ad playing right now, so I'm going to take a hydration break and I'll see you guys in 30 seconds. All right, welcome back. So, we are going to carry on with our Transformers studies, which is here. So we were in the quick tour section, and then there was something in the installation section and adding new models section as well. We'll briefly go over these, but then we need to start going into the other stuff as well. So there's running inference, there's writing portable code with autoclass. Um, Pre-processed data, I need to look into that as well. Oh, I've also been doing research into various components, various NLP related components, because I do want to learn NLP. I want to get into doing NLP. At some point, I want to try and make um, an LLM from scratch. Definitely won't be able to make something as good as, some of the state of the art models right now, but I'm not trying to. I'm trying to make just an LLM. Later on, I could fine tune an LLM to, um, I guess, behave a certain way and talk a certain way and have certain kinds of information or perform certain specific tasks. I'm curious. I'm curious as to how um, character AI's how character AI's tech works in the background. I want to try looking into something like that because I'm interested in various. So okay, NLP is just one. It's just one component of um of creating an LLM. I don't just want to create an LLM. I want to create an agent an agent is like the best term I'm able to come up with. I want to essentially create a bot, but like I don't want to call it a bot. I want to create an agent, which agent kind of makes sense here as well, right? Agent makes a lot more sense in this context. Either way, bot, agent, program, whatever. I want to create, it's not just going to be one program either. Or it could all be in one program, depending on how I set the thing up. But yeah, I want to create an agent that I can interact with, but not only interact with, I want to be able to fine tune various things about it. I want to be able to change its personality. I want to be able to give it a personality to begin with. I want to introduce the concept of memory in there. To a certain extent, LLMs do have memory, but they are very bad at remembering stuff. So like their memory only lasts for a couple of messages, and then they slowly start to lose context of what the conversation was. And I kind of want to study this as well. This is also why I want to start with NLP and then slowly towards um, go slowly towards what was I saying? Yeah, I want to start with NLP and then go slowly towards LLMs, because in creating an LLM, there's going to be a lot of other stuff that I'm going to learn as well. There's going to be a lot of stuff for me to explore tech wise. Um, so hopefully, once I explore that, I'll get a better understanding of exactly how LLMs work and what kind of math is going on in the background. I don't just want to use LLMs. I want to actually create something myself. I don't know what kind of neural network gets used for that, or it might be like a combination of multiple different types of layers. Like it probably wouldn't just be a feed forward neural network or only a convolu. I don't even know if convolutional neural networks get used in LLMs. Uh, I don't even know to what extent recurrent neural networks get used. Um, but yeah, I wanna explore all of that. Once we finish this quick tour section, I think I was still in this thing. Wait, use another model and tokenizer in the pipeline. I think I finished that. I think I finished that bit already. Yeah, I think I finished that bit already. Give me a second. Just a second. Okay, I'm back. Sorry about that. Um, so where was I? I need to look. I think I need to go from the beginning of this. Also, I looked at this table at the beginning when I had started learning about transformers, but I don't think I looked into too many of the other tasks. I think I did, like, to a certain extent, like image. So okay, definitely image segmentation. We've been doing a ton of that. There's image classification, object detection. I haven't done a whole lot of stuff with audio classification. The only thing that I did was whatever the example guided us through. I want to look into automatic speech recognition as well. That's definitely something I'm interested in because I want to set up my own speech to text system. I still have to see what the specifics are around that. What else? Okay, visual question answering. Answer a question about the image, given an image and Dude, okay, hold up. Wait a minute. Hey, Sarah. Hello, hello. Hello again, actually. What's up? I did not look into visual question and answering. We can try that, actually. We can try that right now. Um, Sarah, I'm not sure what I'm looking at. But yeah, you found the right person. That's the person whose stream I was talking about. You found the right. Actually, I gave the person a shout out. That's probably how you found it's probably how you found the person. Give me a second. I will just give me a couple of seconds again. Hold on, just a second. Okay, I'm back. Yes, I know they were trying to figure out who to rate because I had their stream open on another screen. Uh, I usually I usually have someone else's stream running um, when I'm streaming as well. Um, yeah, yeah. Okay. So, anyways, back to what we were doing. So, visual question and answering. This could probably help us do what I was trying to do. Like, okay, what is this expecting in terms of okay, so I'm just gonna take a guess that the thing expects we're gonna use the default um hold on. I need to get the image in here. I'm gonna need to I could just bring in that yeah, I could just bring this what do you call it? This data set in. Give it a second. I think it also needs to download the data set and then hold on. Did it add? I don't know if it added. Yeah, yeah, it added. Okay. All right, cool. Maybe, oh yeah, the thing is the thing still hasn't run. So I think after I run it the first time, let's not try to list anything because that's going to be a fairly long list. What I could do is in here I could probably just copy the image that I was using here. Let's use this image path. All right, so that should be done. No, it's still running. Okay, all right. So we have our image path. Then we'll create our pipeline. So this is going to be our QA or VQA uh, pipeline. What am I supposed to call this? Yeah, okay. VQA pipeline equals pipeline. The task we are going for is VQA. We don't have any specific model in mind. You know what? I'm curious about what models are available on Hugging Face. Yeah, let's see which models are available for visual question and answering. Visual question and answering. Okay, so there's one thing here, and there's also, okay, so we have filtered it out. It seems like Google has one as well, specifically for visual question answering. Then who else? Who else? Microsoft has one as well. You know what? Let's try Google's one. Then we can try Microsoft's one. Microsoft, no, Google has a couple of others. Wait, they have chart to text? I'm curious about this, dude. Yo, I'm curious about this. Chart to text. What does this come under? Visual question answering. Okay. This model is the matcha model, I guess, fine-tuned on chart to text Statista dataset. This fine-tuned checkpoint, dude. You know what I want to do? Once we get a little more experienced with building neural networks, I want to build a model that can actually be fine-tuned. I think at some point in the tutorial, PyTorch does teach how to build a fine-tunable model. So um, I think in that case you have a couple of different types of parameters. You have your hyperparameters, which are parameters outside of the model. These are parameters that are in control of how the training is done, usually, right? Then you have your regular parameters, which are your weights and biases and anything extra that might be added in there, which I still don't know too much about. But definitely the weights and biases are part of the regular parameters. And then you have tunable parameters. That is something I haven't explored yet. Basically, parameters that can be tuned. Now, are the regular parameters being tuned through the fine tuning, or is it that we introduce an extra layer on top of the model? Like conceptually, we introduce an extra layer on top, which is the fine tunable layer. I'm curious. We're gonna have to explore this more later on. Though for now, okay, using the model is um, pix to pix to s struct processor. All right, so that's the processor. That's the model. What is the processor for? Is it for pre-processing the image or is it for something else? Okay, URL is for what? It's for the image. Okay. I'm guessing that's where our, oh yeah, the URL gets used here. So we open up an image. All right, fine. We can do that. Actually, I could, you know what? I could look for a data set of charts and graphs. I'm sure someone has uploaded a data set of just charts and graphs, and then we can test that out here. Then we have input. Processor is okay. This is interesting. So they're not using just the pipeline. They're using like pieces. Yeah, they're using pieces. So in the case of um, text related stuff, there would be a tokenizer and then the model. So you tokenize you tokenize the text, and then you feed the tokens into the model. In this case, we have this preprocessor or just processor, which is processing the data into something, and then that something gets fed into this model. You should ask specific questions to the model in order to get consistent generations. Here we are asking the model whether the sum of the values that are in a chart, no, that are in a chart are greater than the largest value. Oh, they're saying you need to ask specific questions. What if I want to try and get a summary of the entire thing? Yeah, yeah. What if I want to get a summary? Also, if we are feeding in charts, what if we are able to feed in data directly and try and get a summary of that data? Uh, let's see what the model is able to say about that data. The thing is, though, the model is going to have to perform a bunch of different like tests and it's going to have to do a bunch of math, which is why I'm not entirely sure it's going to be that accurate unless you specifically make the model for that purpose. Because, like, in terms of analyzing the data, there's a bunch of different tests that have to be done on it. You you can pass that data through multiple different algorithms. You can process the data in different ways so that it can be standardized or scaled down to an amount where it can be given uh, into a specific model without worrying about the value being too big and stuff like that. Where was I going with this? I was going somewhere with this. Shit, I forgot what I was saying. Yeah, I okay. The more I tried to remember it, the more I just kept forgetting, and now I don't know where I was going with that. But yeah, okay. So, the raw data thing, I'm gonna have to look into it later. For now, though, let's just feed images into this because I do know how to plot the data, right? So what I could do is I could plot. Though if we are plotting data, we would be limited to two-dimensional data. While we are limited to two-dimensional data, we could still try and find patterns even in two-dimensional data. I want to see what kind of patterns this model would be able to find, and it does mention to ask very specific questions. What is PEW? Fine tune on so and so dataset. This is better suited for chart summarization task. Okay, and this. is, well, no, this is also better suited for that. So what's the difference between the two? So one is, maybe if I look into the Statista data set and the, the Pew data set. Okay, hold on. Visual language data such as plots, charts, and infographics are ubiquitous in the human world. However, visual state-of-the-art vision language models do not perform well on these data. We propose matcha, math reasoning, and chart de-rendering pre-training. Okay, so that's what matcha means. To enhance visual language models' capabilities jointly, modeling charts slash plots and language data. Specifically, we propose several pre-training tasks that cover plot deconstruction and numerical reasoning, which are the key capabilities in visual language modeling. All right, okay. Um, okay, so we'll play around with this more. I'm definitely gonna stick with this. So I'm glad that I'm okay, dude. I need to at some point later I need to I'm glad that I looked into this because like looking into visual question answering, even though my head was in like a different place. I was thinking of different visual question and answering related tasks, but my mind didn't really go towards this. That, oh yeah, what if we could feed it images of certain graphs and charts and stuff and have it answer questions about that data? I want to see how accurate that data is going to be. I also need to see what is the difference between these two. Oh, what more do we have? So we found the Google thing. Um, and I'm glad that they named it in this way because I wouldn't have guessed that it's for that specific purpose. Um, what is dplot? Oh, dplot might also be for something similar, right? Dplot as in de-rendering the plot or deconstructing the plot. Yeah, there it is. So we have an image and we get a description from the image and then we feed that into an LLM and give it a question. Wait, is the LLM a part of the model or is it just dplot? Visual language and so. Okay, okay, okay. Especially on complex human written queries. This paper presents the first one shot solution to visual language reasoning. We decompose the challenge of visual language reasoning into two steps: plot to text translation and reasoning over the translated text. Holy shit. The key in this method is a modality conversion module named as dplot, which translates the image of a plot to a linearized table. The output of dplot. So I'm guessing then it could present it as like a pandas data frame or something, and then we could do all sorts of different stuff with that data. The output of dplot can then be directly used to prompt a pre-trained large language model, exploiting the few-shot reasoning capabilities of LLMs. To obtain dplot, we standardize the plot table task by establishing unified task formats and metrics and train dplot end-to-end on this task. Dplot can then be used off the shelf together with LLMs in a plug-and-play fashion, compared with a state-of-the-art model fine-tuned on more than 28,000 data points. Dplot plus LLM with just one-shot prompting achieves a 24% improvement over fine-tuned state-of-the-art on human written queries from the task of chart QA. Okay. Picks to struct for conditional generation. Right. So which one should I be using here? What does the other one give? Because it had like a similar thing going on. No, this gives like multiple outputs. And then what does this give? This also has a similar thing. So I think both of these are similar. It's just that they've been fine-tuned on different data sets. I need to understand what the different data sets do. Give me a second while I look this up. Okay, so Google's own data set. This model is where's the data set that they trained on? Okay, you know what? We can test out any one because okay, hold up. This gives multiple things, right? So let's do something here. Let's use this model. Let's copy the model name, which is here. Okay, and let's bring that in here. Oh shit, I'm gonna need a charts data set. We can find one. We can find one. That's fine. Model name equals that. So then we do model name equals model name. Um, is it model name or is it no, I think it's just called model. I don't think I need to call it model. I don't think the argument is called model name. Okay, right. So then what? We need to import a couple more things in here. So we do I need to look into what pix to struct is. Pix to struct processor. I'm guessing it just means like taking it quite literally. I think it just means that uh it's going to be like a pixel to some kind of binary structure or a structure that's represented as bytes or basically image to some kind of structure that's represented as bytes. And I think it does processing as well. I'm going to have to look into what's going on there because yeah, you know what, let's try looking that up. How do I access the API? um all right, let's just type this. um right, hold on, give me a second. Pix to struct, there it is. Oh yeah, I forgot. Transformers, it has the API thing down here. Because I remember I'd found tokenizer down there as well. Yeah, there's the API thing, and there's each of the classes. And wait, is pix to struct part of this? it might be under image processor. Uh, yeah, let's open that as well. And okay, the pix2struct model was proposed in. Wait, this is a separate model? I mean, yeah, okay, that makes sense, right? Because in that way, looking at tokenizer and embedding and all of that, like each of these are also usually models that you pass some data through. Uh, pix2struct config. Okay. Processor. Constructs a pix2struct processor which wraps a BERT tokenizer and pix2struct image processor into a single processor. What's the output of this? I'm guessing this model. Which model was I using? I forgot. I think I think it was this. I think it was this. So yeah. So from what I remember, it does automatically pull the relevant other components, right? So it's not just the model, it's also if the model has some kind of tokenizer, it'll pull the tokenizer. If it has some other component, which is the case here, this processor, I think it's going to pull that as well. Do I need to add this though? Let's see what IntelliSense says. I think I need to. I think I need to add. Oh, I need to add pipeline as well. I didn't think about that. Uh, pipeline. Okay. Yeah, you know what? Pix2struct processor, and then what else was there in the model? Though, you know what? I mean, this is showing how to use the thing with two separate components. I don't think I would need to do that. I think actually no, I don't know if pipelines is gonna handle the data in this way, because what it's saying here is that you know what, we can test it out. So we can first do it manually with the processor. We pass the image into the processor and get the data from that, um, and store that into inputs, and then pass that into the model. And then we can have just that one task itself, which is visual, yeah, visual question and answering. And then we can just pass the input image directly into that and see what it says. Because here they're using these things separately, right? And it's pulling what it needs to pull from here. So it has the model, and it has the main model, and it also has the tokenizer. I'm assuming it's a tokenizer because it says it wraps the BERT tokenizer. So we have the processor, and then I mean we could wait for IntelliSense to work, or we could just do this. Yeah, pix2struct for conditional generation. Okay, cool. So we run this. And then we have to run this thing. So let's prepare this. We can get rid of the pipeline for now. What was the thing? So we have processor equals pix to struct processor. Oh, cool. Okay, IntelliSense is working. Great. What is it expecting? Image processor and tokenizer. Wait, this is expecting an image processor and tokenizer? An instance of so and so, an instance of so and so. Oh, that's what I have to do from pre-trained. So then here we just need to give the name of the model, and then we create the model thing itself, which is pix to struct. What was it? Conditional something? Yeah, for conditional generation dot from pre-trained model. Okay. So this might take a couple of minutes to download. Fortunately, it'll be faster than if I was doing it on my system. We're going to need to look for a data set. Yeah, we're going to need to look for a data set real quick. Let me do something here. I think if I just look up charts, then there's going to be a bunch of different Spotify charts, Spotify charts, Spotify charts. That's not the charts that I'm looking for, dude. I'm looking for let's look for graphs. Social graphs, snap graphs, API secure. Oh God, dude. Let's try looking for plot. Okay, so the issue is that there's tons of stuff. So I need to find the thing that I'm looking for. Oh, you know what I could do? Let's try matplotlib. What if I look for VQA chart? Actually, I could search for this here. That's not a problem. Okay, so this keeps saying Spotify charts. I'm looking for simple like bar graphs and stuff like that. Stock chart patterns. Yeah, yeah, we could use that. We could use that. Um, bar graph. Uh, let's see, because the cover image doesn't seem to be show. The cover image doesn't seem to be showing. So this might work. Uh, patterns, segmentation. Right, so these are line graphs or line charts. Is there anything else that I can look at? Oh, okay. You know what I could do? I could plot a simple thing and then save that as an image and then pass that image into, you know, I could do that. Or like convert the image as a PIL image or something and then feed that into the model. Yeah, yeah, I could do that. But also, um, so I hate to do this, but I need to end the stream because well, it's getting kind of late. So I started the stream late and I wasn't sure how long I was gonna be able to go. But yeah, I need to end the stream for now. I'll try and stream again tomorrow. I want to get back into, you know, basically resume streaming. So yeah, yeah. Hopefully in the next week, I'm gonna be doing a whole lot more streaming, and we're gonna carry on with, more Transformers stuff. But yeah, for now, I'm gonna spend some time messing around with this because I'm interested. Okay. But that being said, that's gonna be it for today's stream. Sarah, thank you for hanging out. Appreciate you being here and chatting. Anyone else who might have been lurking in the chat, thanks for hanging out. Appreciate you being here. I hope you guys have a nice day, and I'll see you all next time. Peace.